Welcome to bankersbliss.com. I am Karthik Gupta. Today I am going to teach you HCF and LCM. So, important topic. You can expect more problems in PO level rather than clerical level. But clerical level also you can expect a problem from LCM which will be very simple. Within 15 to 20 seconds definitely you can answer any question related to LCM in the clerical level. PO level bit a difficulty level will be high in PO level as well as in the sectional officer level. Okay, HCF and LCM. What do you mean by HCF and what do you mean by LCM? HCF, let us discuss HCF. HCF, fine. HCF is nothing but highest common factor. F indicates factor, C indicates common, H indicates highest. In other words, if I want to say HCF is nothing but GCD, which is nothing but greatest common divisor. One thing you have to understand, what do you mean by factor? Factor is nothing but the divisor. Divisor means the number which is going to divide the other number. The number which is going to divide is called the divisor. For example, consider three numbers. The three numbers are 5, 10 and 15. 5, 10 and 15. So, consider the factors of 5 or the divisors of 5. What are the numbers which divides 5? So, the numbers which divides 5 are 1, 5. Next, consider number 10. The numbers which divides 10 are 1, 2, 5, 10. Next, consider the number 15. So, the numbers which is going to divide 15 are 1, 3, 5, 10. So, we have listed out the factors of these three numbers. So, now I have to identify the common factors for these three numbers. The common factors for these three numbers are 1 and 5, not 2 and 3, 1 and 5. It's not 10, it's 15 here. So, 1 and 5 are the common factors. Among the common factors, which is the highest one? So, among the common factors 1 and 5, 5 is the highest and it is the HCF or GCD, highest common factor. So, this is the basic thing. Highest common factors. So, factors are nothing but the divisors which are going to divide the numbers. So, three numbers 5, 10 and 15. So, 1 and 5 are the common factors and 5 is the HCF. Let us go for factorization method. So, whatever we have discussed till now, it is nothing but the factorization method. Let me tell you the different example. For example, 4, 8, 12. So, the factors of 4 are 2 2s are 4, 2 1s are 2. Next, for factors for 8 are 2 4s are 8, 2 2s are 4, 2 1s are 2. And for 12, 2 6s are 12, 2 3s are 6, 3 1s are 3. So, we have identified the prime factors of all the three numbers. The prime factors for 4 is 1 and 2, and for 8 also 1 and 2, and for 12 also 1, 2 and 3. So, the factors are 1 into 2 square, we can write. For 8 we can write it as 1 into 2 cube, and for 12 we can write it as 1 into 2 square into 3. 1 into 2 square into 3. So, among the three I have to identify the common and it should be the highest one. So, 1 is the common as well as 2 square is the common. Here you may see like this 2 cube. This 2 cube also includes 2 square. So 2 square into 2 is nothing but 2 cube. So the highest common factor is 2 square, 2 square and 2 square, which is nothing but 4. So 4 is the HCF for the 3 numbers. So this is called factorization method. One more method is there, which is called division method. See, if the numbers are very simple, yes, factorization method is the feasible one. If the numbers are complicated, a bigger number, the magnitude is bigger than the 4, 8 and 12. So at that time, factorization method doesn't suit. So you have to go for the division method. Consider the example. Example 150 and 225. These are the two numbers. I have to identify the HCF for these two numbers, 150 and 225. So 150, 225. Which is the highest number here among the two? 225 is the highest. So you divide 225 from 150. So how many times you can divide? One time. So 150 ones are 150. So the remainder is 75. The remainder is 75. Now 75 and 150, two numbers are here. Among the two, which is the highest one? 150 is the highest one. So you divide 150 from 75. So 75 twos are 150. 150. So the remainder is 0. In one side, you should get the remainder as 0. Till that, you have to do the same procedure again and again till you get 0 in one of the side. Another side, you will get a number. That number will be the HCF. Here the number is 75. Here the number is 75. Therefore 75 is the HCF. So this is the division method. If you get 3 numbers instead of 2 numbers, if you get 3 numbers and you have to identify the HCF for those 3 numbers. Consider an example. Consider an example. So consider the 3 numbers. Consider the 3 numbers. Let it be 75, 216, next 170. Let it be 75, 216 and 170. You consider any two among the 3. You may consider 75 and 216 or 75 and 170 or 216 and 170. You may consider any two among the 3. Here I am considering 75 and 216. So which is the highest number? 216 is the highest number. So you divide 216 from 75. So you divide 216 from 75. So 75 how many times you can do? 75 twos are 150, 3 times, which is more than 216. So you divide for 2 times. 75 into 2, which is 150. So what is the remainder? So 6, 21 minus 5, 6. So 66 is the remainder. Now 75 and 66, which is the higher one? So 75 is the highest one. So you divide 75 from 66. So how many times? So 1 time. 66 ones are 66. 66 ones are 66. So what is the remainder? 9 is the remainder. Now which is the highest one? 66 or 9? 66 is the highest one. So you divide 66 from 9. So 9 5s are 45, 9 6s are 54, 9 7s are 63. So 7 times you can do. So 9 7s are 63. So the remainder is 3. Now which is the highest one? 9 or 3? 9 is the highest one. So you divide 9 from 3. So 3 how many times? 3 3s are 9. So the remainder is 0. So till you have to divide to get 0. One side you got 0, therefore the other side the number what you got will be the HCF. Here you got 3, so 3 is the HCF for 75 and 216. Still 170 is remaining. Now you calculate the HCF for 3 and 170. 3 and 170. So how many times you will get? 3 and 170. So 3 5s are 15. 3 5s are 15. So if you divide 170 by 3, if you divide 170 by 3, 3 5s are 15. So 2 carry over 0, 3 6s are 18. 3 6s are 18. So 56 times you can do. 56 times, 6 3s are 18, 1 carry over, 3 5s are 15 plus 1, 168. So 56 times you can do. So the remainder is 2. Now, which is the highest one? 3 or 2? 3 is the highest one. So you divide 3 from 2. 2 1s are 2. 2 1s are 2. The remainder is 1. Now, which is the highest one? 1 or 2? 2 is the highest one. So you divide 2 from 1. So 1 2s are 2. The remainder is 0. If the remainder is 0, in the other part you have to check. Here in the other part you got 1. Therefore, 1 is the HCF for the numbers 75, 216 and 170. 1 is the HCF for 75, 216 and 170. This is all about HCF. So in the HCF we have discussed the factorization method as well as the division method. You know what you mean by HCF, highest common factor. Factors are nothing but the divisors. Okay. Let us go to the LCM. What do you mean by LCM? What do you mean by LCM? What is the difference between HCF and LCM? See, LCM, least common multiple. Now, what do you mean by multiple? LCM, least common multiple. Least common multiple. So, what do you mean by multiple? For example, you take 10, number 10 and you have two numbers 2 and 5. 2 can divide 10 and 5 can divide 10. So, 10 is the multiple of 2 and 5. You take one more number, the one more number such as 15. So, 3 and 5, you take two numbers. 3 can divide 15 and 5 can divide 15. So, 15 is the multiple of 3 and 5. You can get 30 also. You can get 30 also. So, 30 is divisible by 3 and 30 is divisible by 5. Therefore, 30 is the multiple of 3 and 5. So, now I believe that you have understood the multiple. What do you mean by multiple? So, if the number is divisible by the other numbers, then the number is the multiple of those numbers. For example, 15 is divisible by 3 and 5, therefore 15 is the multiple of 3 and 5. So, multiple, yes. Now, common multiple, least common multiple. Common multiple, yes, 15 is common for 3 as well as 5. 15 is common for 3 as well as 5. Now, least common multiple. What do you mean by least here? For example, you take the number 3, 5. You calculate the LCM. This is the procedure to calculate the LCM. So, 3 1s are 3. So, 5 as it is you take next. 5 1s are 5. So, the LCM is 3 into 5 into 1 into 1, which is equal to 15. So, 15 is the LCM. So, 15 is the least common multiple for 3 and 5. Below 15, you won't get any common multiple for 3 and 5. For example, if you take 14, it is not the multiple of 3 and 5. If you take 12, it is the multiple of 3, but it is not the multiple of 5. If you take 10, it is the multiple of 5, but it is not the multiple of 3. Okay, if you take 6, it is a multiple of 3, but it is not the multiple of 5. If you take 5, it is a multiple of 5, but it is not the multiple of 3. So, 15 is the least common multiple for 3 and 5. Above 15, yes, infinite times you will get the multiples 30, 45, 60, 75, so on. It comes like that. So, 15 is the least common multiple for 3 and 5. So, it is very easy to calculate. It is very easy to calculate. Instead of doing like this, if the number is very small, see, instead of doing this procedure 3, 5, so if the number is very small, you can do like this. 3, 5. So which is the highest number here? 5. Is 5 divisible by 5? Yes, but it is not divisible by 3. Therefore, 5 is not the LCM. So next multiple of 5 is 10. Is 10 divisible by 3? No. Therefore, 10 is not the LCM. Next multiple of 5 is 15. Is 15 divisible by 3? Yes, it is divisible by 3. Therefore, 15 is the LCM. 15 is the LCM. Okay. So there is a relationship exists between HCF and LCM. There is a relationship exists between the HCF and LCM. The relationship is the product of the two numbers A and B. The product of the two numbers will be equal to the product of their HCF and LCM. Product of their HCF and LCM. So this is the relationship exists between the two numbers A and B. So the product of the two numbers A into B is equal to product of the two numbers, product of HCF and LCM. Very important relationship, very important relationship. And one more thing, calculation of the HCF of the fractions as well as the LCM of the fractions. So calculation of the HCF of fractions is not the normal method, we have to go for a different method. Okay, let us discuss how to calculate the HCF of fractions. So HCF of fractions. So HCF of fractions, HCF of fraction is equal to HCF of numerator divided by LCM of denominator. HCF of numerator divided by LCM of denominator. For example, you have a fractions like this: 1 by 3, 1 by 4, 8 by 11, 8 by 11. So now, what is the HCF of numerator? So 1, 1, 8. Obviously, the HCF should be 1. Obviously, the HCF should be 1. And what is the LCM for the denominator? 3, 4, 11. So which is the highest number here? 11. Otherwise, you take the two numbers 3 and 4. So what is the LCM? 3 is the prime number. So directly you multiply 3 to the number 4, you will get the LCM of 3 and 4. See, if a number is prime, any one of the number is prime, then directly you can multiply the number with the another number so that you will get the LCM. So 3 into 4, 12. 12 is the LCM. The next number is 11. So calculate the LCM between 12 and 11. Here also 11 is the prime number. So directly you multiply with the 12. So 12 into 11, 132. 132. So therefore, the HCF of fraction is 1 by 132. 1 divided by 132. If you want to calculate the LCM of the fraction, LCM of fraction, LCM of fraction. So which is equal to LCM of numerator divided by HCF of denominator. HCF of denominator. The reverse manner. While calculating the HCF, we calculated the HCF of numerators and we calculated the LCM of denominator. But while calculating the LCM of the fractions, we are calculating the LCM of numerators and we are calculating the HCF of denominators. For the same number, you calculate the LCM of the fraction. So 1 by 3, 1 by 4 and 1 by 8. 1 by 3, 1 by 4 and 8 by 11. Now 1, 1, 8. What is the LCM? So here you will get 8 as LCM. Next 3, 4, 11. So what is the HCF? See here, among the numbers, if any two of the number is prime in a group, then obviously the HCF will be 1. So 3, 4, 11, 3 and 11 are prime numbers, then obviously the HCF will be 1, therefore the LCM of the fraction will be 8. LCM of the fraction will be 8. So now you have understood what do you mean by HCF, what do you mean by LCM, what is the relationship between the HCF and LCM, next how to calculate the HCF of the fractions and how to calculate the LCM of the fractions.